Okay, so we are going to be doing the chain rule backwards, or in other words, U substitution. And we're going to spend a couple of days on this because, with integration, it's a lot harder than taking the derivatives, and you have to be able to kind of see stuff, and that takes some time. But let's look at this and just go after it. If I ask you the derivative of that function here, I'm sure you say, okay, yeah, I remember the chain rule. I wouldn't just do power to the front and decrease the power of 1. That would be incorrect if I said that was the derivative. I would have to multiply by the inner derivative, right? Okay, well, I spelled that wrong. Derivative. You have to multiply by that inner derivative. So it's kind of, in a sense, something that I don't want to say you did at the end. I mean, as you're taking the derivative of that specific thing, you did do it at the end of that part. So you had to multiply by that inner derivative. Okay, now let's look at this next one. I know these things kind of seem sporadic, but I promise, give me, like, this is one of those lessons that I'm like, you know what, give me like 3 or 4 examples before you say you don't get it, because it just takes a little bit. So let's just look at the integral. I know if I said integrate x to the fifth, you're like, okay, that's a simple problem, but I want to point out something. When I say integrate x to the fifth, I'm really saying integrate x to the fifth. What's in front of that dx? I mean, it's not written, but if I said there has to be some in front, what would you say was in front of there? You would say, well, there's a 1 in front of there. It's really, it's a 1 dx. Do you notice that this 1, if I put parentheses around this x, because what's being raised to the fifth is x, do you see that this is the inner derivative of this? Okay? And we've been integrating 50,000 times, and we said, yeah, if I integrated, I would get 1/6 x to the 6 plus 0, and that would be my answer. Well, what happened to this piece? I mean, what happened to that 1? I mean, it just kind of goes away. I say poof, I put it in a poofy cloud because it poofs away. So here is what it comes down to. What it comes down to is, look, if you have a composition of functions, which you do, when you have an inner derivative not being 1, you have to think of the chain rule, but you kind of have to think of it in a kind of backwards way. When you were doing the derivative, you kind of thought about it at the end. You had to multiply by the inner derivative. Well, when you're integrating, you have to think of it first. So you must have the derivative of the inner function in order to, or before you can, integrate the outer function. You must have the derivative of the inner function before you can integrate the outer function. So let's look at example 1. And I know you're like, why do you have it twice? Well, because there's actually 2 methods in that. I go back and forth in teaching. Do I teach both? Do I emphasize one? But here's the deal. I've got 80 calculus kids, and probably half of them is going to like it one way and half of them the other. So I want to present both, and then you can decide which way on your homework you tend to do better. And sometimes I do even a combination of both. So this stuff is mechanics. It will be on multiple choice. So as far as your work goes, I mean, you're just going to have to be able to get there. So, okay, let's go after it. Well, here's what I want you to see. When you see example 1, you have to go, oh my gosh, I have a product. Well, there is no product rule for integrating. That's the difficulty. For derivative taking, you go, oh, just do the product rule. If I see a product, do the product rule. That was your next step. For products and quotients, y'all, there isn't a product rule. There isn't a quotient rule. So there has to be a reason that that variable is there. Now, for today, pretty much what it comes down to is, okay, if I see a power, do you agree that I am multiplying all these things together? I have 4x cubed, I'm multiplying by that, multiplying by dx. They're all multiplication. So if I wanted to, and I do, I want to write that in a better way. I would rather write it like this. I just change the order. Now, why did I do that? Let's look back to this x to the 5th example. Do you see I have a power, something to the 6th power, right? So I go, oh, I know how to integrate something to the 6th. Yeah, I do the power rule for integration. But do you have your green light? What is the green light is that you have the derivative of the inner function. You cannot do the power rule until you have the derivative of this, just like we had here, sitting next to dx. Now, do you have that? Well, the good news is you go, yeah, I do. The derivative of x to the 4th minus 5 would be 4x cubed. So this is my, I poofy cloud it. I literally on my paper, I poofy cloud it. I'm go, sweet, I have the inner derivative. What happens to it when I integrate? So I have the green light. I can now integrate the outer function. What is the outer function? The outer function is something to the 6th power. Well, how do I integrate something to the 6th power? I raise that something to the 7th power, divide by the new power, and we're back to indefinite, so I have to put plus c. Now, what's in that parentheses? Well, the same thing that was raised to the 6th. So my answer is that. This is my final answer. And you go, whoa, 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 what happened to that 4x cubed? Y'all, it poofy clouds. It goes away. It has to be there for you to take the power rule, for you to integrate with a power rule. Okay? Now, you go, I don't know why this is called u substitution, because like you didn't put u in that whole problem. Because I personally, I like this way better when I can use it. I will tell you there are some times when you cannot. So I'm going to wait to do this other problem, to do that problem again with u substitution. Let's look at example 2. And, oh, what are those dx's doing there? Kind of random. Pretend like those aren't there on the video. I don't know why they're there. So let's look at that. Okay, I have something to the 5th. So I really don't have to rewrite this one, but I'm gonna write stuff on it. So I have 3 plus, I'm just writing this over so I can kind of have space to write, and I'll just use that dx that's randomly there. I don't know why. Okay, so can I do the power rule right now? Am I ready? I see it. I've got an inner function. I've got something to the 5th. Am I able to integrate with the power rule? No. Why not? Because I don't have the green light. Because what is the green light? You must have the derivative of the inner function before you can integrate the outer function. Next to dx, do I have the derivative of the inner function? No. What is the derivative of the inner function? Well, if you look at this, and I ask you just the 3x plus 2, because that's the inner. What's the derivative of that? And you say 3. You wish there was a 3. Y'all, here's what I'm doing. Now, I'm going to do it a lot in one step. I can multiply. I can add 0, and I can multiply by 1. That's the only thing that I can do to not change the problem. So here's what I'm going to do. I'm going to write it up here, and then I'll show you how I write it. I am going to say, you know what? I am going to multiply by 3 because I want a 3, but I also have to multiply by 1, so I'm going to put a 1/3. Do you see that I'm multiplying by 1? Which is legal, which if I simplified this, I would still be at this. If I just put a 3 in there, those won't be the same thing. So that's ultimately what I'm doing. Now what I'm going to do in a smart way is I'm going to put the placement, I'm going to do the placement wisely. Yes, I want the 3 to be near the dx. The 1/3, I kind of pull him out and get him out of the way because I like it that way. Some people don't like to put it, they like to put it right here in front there. It doesn't matter. They're the same thing. So know that as you're looking at my keys. Okay, I like to pull it outside the integral. I just get it out of the way. Now watch. Let me finish this problem. Do I have the green light? Do I have the derivative of the inner function? Yes. So I can now integrate the outer function, which is something to the 5th. That would be something to the 6th. Sorry, don't need that integral symbol. Something to the 6th times 1/6. Now don't forget that I had the 1/3 out there. Have to remember the plus c. And of course, what goes in that parentheses is the same thing that was in the parentheses here. So my final answer is going to be 1/18 3x plus 2 to the 6th plus c. And there's my answer. So I like that way. Now, again, now you're going, okay, what is this U substitution? I call this, and I refer to it as the quick way of U substitution, because on a lot of problems, you can do this kind of quicker way. On some problems, you have to do it the long way, but some of you might like this other way better because it helps you see it better. Y'all, I'm not going to tell you which way you have to do it, but I want to show you the other way, and I need you to watch. Don't go, oh, I like this way, so I'm not going to listen. You have to listen because in a couple of days, there'll be some that you have to do the true U sub way. So I call this true U sub. You'll see the similarities. In this problem right here, I would still, if I were doing this true U sub, I would still rearrange. And what true U substitution does is you substitute, hence the word U sub, if you have a power, a very common thing for your U is your inner function. So your U is going to be your inner function. Now, underneath that, are you in agreement that I could write this as du over dx, the derivative of u with respect to x is what that's saying, is 4x to the 3rd. You agree with that? And you've probably always looked at that du and dx as being one thing. Well, they're totally different. They're two different things. I mean, you have your change in u over your change of x. It's really slope, right? So that I can disconnect those things. So really, and like I said, after this time, you'll probably just go to this step. You're like, oh, du is 4x cubed dx. Now, the whole point of u substitution is look at it this way. What is this thing? Well, that's u. I have u to the 6th. What is this thing? Well, oh my goodness. All of that is du. So if I handed you that problem and said, y'all integrate u to the 6th with respect to u, you'd say that's 1/7 u to the 7th plus c. But my question, I don't need my answer in terms of u, I want it in terms of x, so my final answer is 1/7. U was x to the 4th minus 5 to the 7th plus c, and notice I get the exact same thing. So that's u sub. Now let's look at the next one that we did. If you were, again, I don't know what that dx is there on the screen there, so I'm just going to rewrite the problem because it bugs me to have that there. Okay. So if you like the u sub, you're going to let your u be the inner function. So when you see a power, a lot of times it's that inner, what you're raising to the power. And so I am going to do du over dx. So du dx, the derivative of u with respect to x is 3, but then I'm just going to put the dx on that side. Okay, now let's look at this one. U substitution, I've got to rearrange and replace all this stuff with u's. Well, this part is easy. That's u to the fifth. Now notice this says dx. Y'all, if I looked right here, do you see that I could solve dx and I would get du over 3, or better yet, 1/3 du? So I'm going to replace dx, because you got to replace all the x's, with 1/3 du. Now, here is a big difference and I need you to get it. Is this 1/3 in the integration right now? And you're like, yeah. If that 1/3 is in the problem and I want to move him to the outside, do I put a 1/3 there or a 3 there? Well, I put a 1/3. It was different from over here when this 3 was not there and I had to put it in and take it out because I have to multiply by 1. This 1/3 is in the problem. I'm literally moving him. So as you can see, I'm integrating and doing the same thing as I did here. So I have u to the 6th times 1/6 times 1/3 plus c. And my last step is to replace, and I get this. Now, those are the two methods. And so, unfortunately, with you, watching this video, you're not in class, so I can't ask, okay, I'm not going to solve every problem 2 ways. So I would ask the class, hey, which one do you like? My guess is that most of you like this shorter way. I mean, this is just, man, that's a lot of writing of something I can do very, very quickly. So when it comes to timing of tests, and all these DXs are killing me. It's just very weird to me. Then you would have that. And I think, again, there's somehow the worksheet and the what you have are different. So I'm going to put these are in your worksheet without those DXs. So I don't know what's happening, but there we go. So let's look at this. So I'm going to do this the fast way. And I think it helps you recognize it a little bit. And so here we go. Okay. I have 3. I'm just recopying it again so I can have some space. I see something to the power of 8. I ask myself what the inner derivative of that is. And you guys, listen, some people do a combination. Like they would write, okay, let me write this down. 3 minus 7x, what would du be? Du would be negative 7 dx. That right there, that's cool to write. Because you're like, oh, I need a negative 7 by dx. If you don't have a constant, you can fix a constant. When we get to problems where you have an extra x or not enough x's, that's when we have to do true u sub. But if you can fix the derivative with a constant, then you're good to go. So I could say, look, I wish I had a negative 7. But if I have negative 7, I have to multiply by 1. So if I multiply by negative 7, what else do I have to multiply by? Well, I have to multiply by negative 1/7. Because if I multiply those two things together, I'm multiplying by 1. Do you have the green light of integration? Well, I have the inner derivative. So what can I do? I can integrate the outer function, which is something to the 8th power. I don't know why I keep writing that dadgum integral. So I have something to the 9th, to the 1/9. I can't forget the negative 1/7 that is right here. And of course, what's in that parentheses is the same that was there, plus c. And to finish that problem, I write 1 over 63, negative 1 over 63, 3 minus 7x to the 9th plus c. Okay. All right. Number 4, let's just keep practicing. Okay, so this one is a quotient. There is no quotient rule. So I have to think about how to write this wisely. So I'm going to write this part right here, the square root. Wouldn't that be 4x plus 5 to the negative 1/2 dx? Now this 3, this would be times 3. Do you agree? Now listen, I can handle this 3 a couple different ways. Personally, what I like to do when you have something like that, I like to get him out of my way. Now, notice I put a 3 on the outside. I did not put a 1/3 because this 3 is in the problem already. So I'm literally just moving him. So I've pulled him outside the integral. So now what do I need to do? Well, what is my inner function? My u would be 4x plus 5. What would du be? That would be 4 dx. What do you need next to dx? You need a 4. Okay, cool. Now that 4 is not there. So if I put in a 4, what do I have to multiply on the outside? I have to multiply a 1/4, so I'm multiplying by 1. Once I have my green light, this is my green light. I have the derivative of the inner. Now I can integrate the outer. I increase the power by 1, so that would be 1/2. I divide by the new power. So dividing by 1/2 is multiplying by 2. And of course, I have this stuff on the outside. That's 3/4. What's in my parentheses is the same. Can't forget my plus c. Now just finish up the problem. Do the multiplication, that would be 2. So I have 3/2, and most likely, like we've done before, when you have something to the 1/2, they tend to write it as a square root plus c. So do you see how I say I kind of do in a sense, I like doing kind of a combination of the u sub, like I write out the u and the du to see if I can fix it with a constant, which I'll be honest, on your homework problems today, that's going to be true. But as we move further, it won't be. So that means if you can, again, if you can fix it with a constant, that's when you know you can do it kind of the faster way. So let's look at example 5. Let's see if you can try example 5 on your own. So stop the video and give it a go. And if you like the true u substitution, by all means do it that way. Okay, you have to do it in the way that you understand. So here's what I would do to do this problem. I would write the integral. I would have 5x squared. I see my power, I put that first. Now I have an x dx. Okay, because I have this variable. This 7, again, numbers that are already in there, especially when I can tell it's not my derivative, man, I just move him to the outside. Get him out of the way. He's bugging me. Okay, so what is my u? My u is the inner function, 5x squared minus 1. So what would du be? Du, the derivative of u with respect to x, is 10x dx. Sweet friends, do you see, you're like, oh, I'm so thankful that that x is there. Because if I need to get this, I can't put in variables. So the variables have to match up. If the variables don't match up, we have to do it a lot longer way. We have to do true u sub, and they're going to get ugly. If the variables are right, that x is there because it's the inner derivative. The only thing I'm missing is a 10. So sweet. Put in a 10. You put in the 10. So you have to take out the 10. I think you're okay with me. I'm multiplying by 1/10. So just putting over 10 out there. Do you see that I'm multiplying by 1? I am putting a number that is not in the problem. So I have to multiply by 1. Okay, so now here's the part that people always ask me. I've poofy clouded every single thing. Right here, you didn't say, what happened to that -7? What happened to that 4? But for some reason, when there's a variable, I'm like, y'all, this is the inner derivative. You have the green light. Now, integrate the outer function. You have something to the ninth, divide by the new power. Of course, you have the 7/10 on the outside. What's in the parentheses stays, plus c. And of course, I simplify that to 7/90. 5x squared minus 1 to the ninth plus c, and that's my answer. And when I do it like that, people go, wait, what happened to that x? Y'all, it's in the poofy cloud. It poofed away. Just like all our other variables, it poofed, our numbers, it poofed away. It had to be there to give you the green light. That's why it's there. Okay, let's look at number 6. I think it's very important on number 6, like doing it this way, like kind of writing that out. It kind of helps you see it. And y'all, this is why doing your homework is important. I see these problems very easily because I've done 5,000 of them. You have done, well, at this point, 5 of them in examples 1, 2, 3, 4, 5. Okay, you've done none on your own. So I can see these problems. You can't right now. You only get better by practicing. So I'm telling you, you have got to practice this stuff. So let's look at example 6. I see a power. I see a square root, but I know it's probably smart of me to write that to the negative 1/3. And then I'm going to put in parentheses, I have an x plus 1 dx. Do you agree with that? And you're like, okay, I've got a product, so somehow that there's probably a reason that x is there. Let's see if we can figure it out. Well, let's figure out what our u would be. Our u would be 2x squared, my inner function, plus 4x plus 5. What would du be? Du would be 4x plus 4 dx. I'm going to put parentheses around that. Okay, y'all look. See if you see it. Wait a minute. Wouldn't du, I could write it this way, 4 times x plus 1 dx. Do my variables match up? Oh my goodness, I have that and I have this. What is the only thing that I am missing from to have the inner derivative? The only thing I'm missing is a 4. I have to put a 4 in. I have to take a 4 out. This is my poofy cloud. This is the inner derivative. This is the green light so that I can integrate the outer function. Something to the what power? Increase the power by 1 is 2/3. Divide by the new power. It's easier for me to say multiply by the reciprocal. Of course, I have the 1/4 that's on the outside. What's in the parentheses does not change. Plus c. And the last step is just to clean it up. I have 3/8. 2x squared plus 4x plus 5 to the 2/3 power plus c, and that's my answer. All right, one more. All right, number 7. What do I do for him? Well, if I'm kind of the last examples, if you looked at 4 and 6, those guys, you said, well, every time we had something in the denominator, we kind of moved it up. So we'll just kind of do that same thing. I would have, let me put some parentheses, x plus 2x squared. And then I would have times x to the negative 1/2. Do we agree with that? Okay. So would I say my u is this? It's kind of been that thing. Would I do that? Well, hopefully in this one you're like, wait a minute, this problem is not even a u sub problem. Because notice that this thing is not raised to the 5th power or the 3rd power or the 2nd power. It's just raised to the 1st, which means, wait a minute, in this problem, this is not a u sub problem. I'm just going to distribute, because it's raised to the 1st, I can just get rid of the product myself. Because again, if you have a product with x's, that x has to be part of the derivative or something. Well, this one, yes, you have a product, but you can rewrite the product to not be 1. And so when I distribute, remember you add exponents. So this is really saying x to the 1/2 plus 2x to the 3/2 dx. So what do we know about integrals? I'm just going to go down the line. I can separate these, not that you have to write this step by any means, but you can go down the line and go, okay, I need to integrate that, and then I need to integrate this. So what's our integration? I would increase the power by 1, that's 3/2, multiply by the reciprocal, or divide by that power, so that'd be 2/3, plus increase the power by 1, that would be 5/2, because remember increasing, I'm adding 2 over 2. If I multiply by 2/5, so 2 times 2/5, that would be 4/5. Can't forget the plus c. And, whoa, boy, that was an ugly box. But that would be my answer. So make sure you know that when you're using U sub and when you are not. Okay? Practice, practice, guys. Peace out.